Good afternoon, friends. Let's start. See, you see her picture behind of a beautiful city. When I entered Hyderabad, I have seen the skyline is rising at a very fast rate. And of course, that's sign of growth. So such a beautiful cities, such a buildings are rising at very high rate. But we are not knowing much about the dangers which are hidden within these buildings. We are not sure whether occupants of the building are safe or not. The many accidents are happening every day. I am in different groups. I not a single day passes where I don't hear that some fire has taken place and some accident has happened. See, the main basic two dangers which arise from electricity is the electrocution, that is electrical shock. Humans are facing these electrical shocks and losing their life every day. That figures are very high. The another danger from the electricity is the fire, that is fire due to the short circuit. Why it is of great concern to India? See, there are different organizations working on this, gathering the statistics from all over the world. This is one of the known organization, CTF, International Association of Fire and Rescue Services. It collects worldwide statistics of the fire incidents. You will see here in the graph. You will see here in a graph. See, this is the blue line which you have seen here. It is at the top. It shows number of accidents happening. India stands at the highest. Here in another graph, you will see here that the number of fire deaths occurring in India is the largest. Why it is so? You may say that India's population is very high, so the percentage of person losing life is might be more. But in China, if you see the second line is about the China, that line is less than 50% of the India. India is losing the number in this figure that 23,265 belongs to India, and if you China compared to that, that is 10,488. So here again, this makes us. This tells us that India has to look after this point very seriously. This is another statistics which is collected from the National Crime Records Bureau. Here also, if you see, the number of electrocutions which happened are the fatalities which occurred because of electrical accidents is 12,918, and the survival are just 242. It tells the seriousness about the electrical accidents. If person meets with the electrical accidents, the chances of coming out of that accident is very less. Again, in respect of fires also, the same thing is there. Fire due to short circuits. The lost life figure shows 1,406, and the persons survived out of that are just 122. So we have to take this problem very seriously. See, these are the every day. I told you, every day there is not a single day passes without I hear the news of fire accident has occurred and some property loss has occurred or some fatalities have occurred. So these are the continued horrifying news. So India as on today is at the worst position. So that's why we want to take this problem very seriously. Government is also taking some actions in respect of that. Different high courts of the different states are taking some action. They are telling the government to take some action so that these accidents can be mitigated. So these are the different orders passed by the different states. So we'll try to find out here how the electrical fire gets initiated, why such incidents are arising, what is the role of the architect here. We'll see today's all these points from the point of view of the architect. And what are the regulatory mandates? We are not going into details of the electrical technicalities, but we will see how the electrical requirements correlate with the architect's provision. So basically here, this is the flow. First, if there is faulty design, accident may happen. If the material used in that project is not of proper grade or standard, it may lead to accident. Suppose if the design is good, material is good, but if the installation is carried out in defective way, then again it may lead to the accident. The coordination which is required in the electrical circuitry design, if it is not properly not chosen, then it will lead to the accidents. Leakage and short circuit is the end result which we face and we lose the lives. See, the water leakages will not cause any person to lose his life, but electrical leakages may cause a person to lose his life. So here the architect's view, architect's perspective come into the picture. See, this is the faulty design. In the faulty design, there are certain requirements which are expected from the architects. If those are not taken care of at the very basic planning stage, it becomes very difficult to clear all these defects at the end. Suppose if some construction has already happened on the basis where there are no proper provisions for the electrical installation, it is very difficult to clear at the end. And then the problem comes whenever you go to some authorities and ask them for certain permission, he will tell you, see, the clearances for this is not proper, we cannot give you the permission. So this question may arise. So at planning stage, the provisions which are architects supposed to do in respect of the making provisions of space and as well as locations, this is a very important point. Second is the defective installation. Certain things are also required for the installation of actually constructing the electrical materials equipments on the site. So this is a point of concern which we expect from the architect. So what are the architectural requirements that we will see? The National Electrical Code has elaborated on this point very, very nicely in the recent their edition, which was published in January 2023. So these are some of the points which we have taken from the National Electrical Code. This is the clearances of the electrical lines from the proposed buildings, the routes and service entry points in the building and within the building complexes, location of electrical apparatus, electrical panels, electrical meter rooms, movement of heavy equipment, that is a practical aspect which you need to consider, shafts and ducts and restricted areas. See, this is one of the requirement which is as mandatory as per the Central Electricity Authority regulations. Some clearances are required from the existing electrical line. These clearances are required from the overhead as well as underground electrical lines, and some parameters are given well explained in the regulations. The 2 points of concern here are the vertical clearances from the line and the horizontal clearances of the line. The regulations do not allow you to construct any structure below electrical line. If you are going to construct in vicinity of electrical line, certain horizontal clearance is required. When this horizontal clearance is required, there you have to consider the exact, I mean the flat distance and the deflection of that overhead line also, because the conductor, electrical conductor may get deflect due to the air pressure. So in accordance, you will have to consider the horizontal clearance also. Different clearances have been mentioned in the regulations depending on the voltage level of the electrical line, whether it is low tension line, 11 kV line or higher or EHV line. In respect of EHV line especially, certain clearances are required apart from the horizontal and vertical clearances. Certain clearances are required below the line, that is called a right of way. That is mandatory to maintain the clearances for this owner of that line to carry out the electrical maintenance, or maybe because of some augmentation which they have to carry out in the future. So this right of way is one of the important requirement which generally is not seen to be maintained properly. Central Electricity Authority regulation tells us in regulation number 65 that you have to take proper permission from the electrical inspector and the owner of that line before carrying out any construction in the vicinity of that line. So some documentation is required and some clearances you need to take from these two authorities before starting your actually construction work. So this is the very important right which is needed to be considered by the architect at the very beginning stage. In the recent edition which was published in June 2023, Central Electricity Authority, certain amendments have been done in respect of the lines which cross the national highways. So it is now mandatory to use underground cable only for the lines up to 22 kV, and above that the clearance which was previously required about 5 to 7 meters from the finished road level, that has now increased to minimum 11.6 meters. This is another point which is again given in the National Electrical Code. You have to plan the underground services within the complex of the building very precisely. For different type of services, there should be some clearances which are mandated in the regulations. Between the electrical line to electrical line, what should be clearances between electrical power cable and control cable, what should be the clearances between power cables and the communication line or the underground water pipelines, what should be the clearances that is given in the CA regulations. So unless you plan that properly and mark all these lines, underground lines on your site plans properly, the project may not be executed as per the rules and regulations. This is one more very important requirement which is required to be maintained. In front of electrical panels, certain clearances are required. These clearances are worked out as per the level of that flashover which may occur at that point. See, the flashover is one of the very, very risky occasion. The temperature which may rise up to the 20,000 degrees, which is more than, above the 4 times the surface of the sun. So there clearances have been mentioned very in detail in the regulations and the electrical codes also. So in accordance, if we don't maintain clearances in front of electrical panels, that may again lead to accident. There, see here the different levels have been mentioned: restricted approach boundary, limited approach boundary, arc flash boundary, and in accordance there has to be some clearance in front of electrical panels. So again, this point has to be considered. Of course, I don't say that architect should be knowing how much clearance is to be maintained. There should be coordination between the electrical designer and the architect. The electrical designer should specify how much clearance is required, and then the architect should make such arrangement in his drawings. One more requirement, you must be knowing that there are independent electrical shafts are required in the building. If we don't maintain those independent electrical shaft, accident may happen. And here, if you will see, this is the actual photo which was taken from one of the buildings in Mumbai. Actually the fire initiated on the 10th floor, and this picture was taken on the 20th floor. Why this happened? There was no proper ceiling at the floor level, and that's why the fire passed from the lower floor to the upper floor. So this is one of the very important requirement given in the National Electrical Code. It is given in the building the rules and regulations of the states also. So this has to be done. The size of shaft, the material, I mean the fire resistance power of that shaft has been quite clearly mentioned in the standards and code. Minimum it is 120 minutes, and the sealants which you use at this level, those should be also fire rating of 120 minutes. Independent shaft is required. The shaft assigned for the electrical cable shall not be used for any other services like your pumping lines or downcomers of the fire system or any LV system. LV system may be allowed within electrical shaft, but there should be segregation between such cables, electrical cables, and this LV system lines. So these are the requirements given in the code. So shafts should be designed in accordance with that. Independent shaft. This shaft should be, as far as possible, should be nearer to the energy meters which will be installed later on in the building. Electrical meter room is again one of the very prime location where the electrical fire begins. This fire may begin because of the fault of any occupant. If the system doesn't get tipped within his flat, then the fire may pass up to the meter room, and once the 1 meter catches the fire, it may again engulf the whole meter room also. So there are different conditions mentioned in the code that you have to consider. That includes the clearances, that includes the openings of the doors of the meter room, that includes the ventilation system required within the meter room also, location of meter room. One more important thing which is important from the perspective of electrical fire is the switch which is mandatory to be installed. That is called the fire switch. That fire switch is required to be operated when the building, then the fire is initiated in the building. The fire person switches off this switch so that the fire may not spread within the building. But for that, one bypass is there which is required for the critical services. So this diagram shows how the circuit should be designed, and its location should be at the point of supply. So the meter room should, the point of supply where the supply enters of the service cable, there should be sufficient space to install this fire switch also. This is one recent amendment which has occurred in June 2023 in the regulations is that I am repeating regulations every time. These are most of these regulations I am telling is about the Central Electricity Authority regulations, and why those are important that we will see later. So in these regulations, under the regulation number 38, they have mentioned that in the service shaft, electrical power cable service shaft, instead of cables, the bus duct shall be used. So if you will see here, this is the bus duct. Because electrical cables may spread the fires, because the insulation may catch fire. The insulation of the cables may be toxic. It may generate some smoke also. So to eliminate that possibility, it has been made mandatory to use the electrical shaft. Now, if you are going to use bus duct in the electrical shaft, it is natural that you may not be able to install your electrical meters at the ground floor. In that case, you will have to install electrical meter on every floor. Suppose this shaft is coming from your ground floor. This is the tap-off switch which is taken from this bus bar, and from this tap-off, a small cable connection is given to this meter box. This is the meter box. And number of flats on that apartments or whatever shoppings or the meters are installed on the same flat. Again, this point comes under the purview of architect, that there should be sufficient space to install meters on each floor. So the design should be made in accordance with that. These meters, it's not necessary that the meter should be installed within the shaft only. Those can be installed outside the shaft also. But of course, provision has to be made for that. Again, shafts and certain conditions have been mentioned. The fire rating of electrical shaft, fire rating of the doors of the shaft. And one more thing, you will see here a chamber, we have shown it here, where for the underground cabling, some chambers are required at certain locations. For these chambers, the size also has to be, you have to consider, consult with the electrical design consultant. He will tell you size of this shaft. Why this size is important? This in the distribution system, it is necessary that if some fault occurs for the cable, to clear that fault, some additional length of cable is required. So this additional length of cable is coiled here in this shaft. So how much will be the diameter of that coil? So that again calculation is there. Electrical designer will tell you he will require the chamber of such and such size. And of course these chambers have to be accessible all the time. Whenever some fault occurs, it should be accessible. It should not get concealed within your paver block or something like that. In the building, National Electrical Code, building code and the standards also, some requirements are given in respect of the wet areas like bathrooms and shower area. In bathroom and shower area, different conditions apply for the electrical installations. There are different zones which have been defined in the regulations and the code, and as per those zones, the risk of fire is categorized. And depending on the risk, there are different requirements in respect of the walls, wall thicknesses also, and clearance to be maintained. So there has to be again coordination between the designer and the architect. If at all sufficient clearances are not able to achieve, then the electrical consultant may have to use a low voltage system, 12 volt system, or even a low 25 volt system also there. So coordination between the electrical designer and architect is very, very important each and every point at the planning stage. Again, I am telling you, before you plan and make your final drawings, it is important. Nowadays, high-rise buildings are coming up very, very fast. I have seen so many high-rise buildings coming up in Hyderabad also. And this is one of the picture of the building from the Mumbai. And it was originally designed for 118-storied building. But now it is restricted, height is restricted somewhere around 89 or 90 floors. So in such case of such building, it is not possible to install the distribution transformers at ground level only, because the length of cables or whatever the bus duct will be very, very high, and it may lead to the voltage drops and loss of energy. So under such cases, it is preferred that the transformer shall be installed on the upper floors also. Even the technical standards which have been published by CEA, that they have also allowed transformer to install on the terrace floor also. So if at all such condition is necessary, architect will have to make provisions in accordance that the substation area they are providing on the particular floor. If the transformer is to be installed on the upper floor, again some question come into the picture that in future there could be some fault in the transformer and they may have to replace that transformer. If such conditions occur for the removing the transformer from the upper floor, bringing it to down, and again replacing the transformer, again here all so many questions are there. Whether the shaft, I mean the vertical transportation system is able to take that much of load and that much of space. Whether the passages from where you are going to remove those heavy electrical equipment, whether those passages are of such width or not. So here again the architect's view and the consultant's view are very, very important. This is the actual pictures which have been shown here in the adjacent frames, that the upper floor the electrical transformers have been installed. And of course these transformers are dry type, not oil type transformer. Why oil type transformers are not there, we will see in our next slide. Transformers are required to be cooled, and the cooling medium is different. The most efficient way to cool the transformer is a liquid. That liquid comes in two classes. It has been mentioned that if you are going to such type of transformer, the oil which you use should be of K class. The K class oil has 300-degree fire point, and it is called esters. Esters comes in two different types. One is synthetic ester and one is natural ester. Both of these oils are allowed under different conditions. So this is the important point which we need to consider. There has to be sufficient space. If you are going to install the oil-filled transformer, it should be away from the bedding, and the liquid which is going to be used in consultation with the electrical designer should be of K class. So in accordance different, so this is one of the standard which is showing how much clearance you have to maintain from the transformer substation and the adjacent structure. The detailed calculations have been depending on the content of the oil and depending on the structure which is adjacent to the your transformer. So there are two classes have been defined. One is bearing system that they call REI, and one is EI, non-load bearing type system. R is the load bearing capacity, E is the fire integrity, and I is the thermal insulation, that is 60 or 90 minutes, which refers to the fire resistance duration in minutes. So in part 3, section 22 of National Electrical Code, the details have been mentioned, and in accordance with that you have to maintain the clearance around the transformer. So this point needs to be considered at the very planning stage, very beginning stage, if at all transformer substation is required or not, what will the load requirement, that assessment also should be correct. How much load will be required, and if transformer is necessary, where it should be placed, and if at all is going to be placed, what is minimum clearance required as per the rules and regulations. There are some other requirements in respect of oil-filled transformers, how the room of that transformer should be designed. See, here is the sill which have been shown here. If the oil drains out, it should be contained within that building, so that the threshold of that that building should be at such a height that the oil may not pass outside that. So these are the different pictures given in the standards and draining arrangement, how it is to be done. Again, this point comes in the purview of architect. In accordance, he has to allocate the spaces and location for all these things. Another point is aesthetics and electrical safety. So interior design is a very, very important point. And see, many accidents happen because the owner of that particular apartment or block, whatever it is, he tries to make changes in his existing electrical installation. Why he tries to do that? Because the points given within that apartment are not as per the requirement of that particular owner or user. Those do not coordinate with the furniture layouts. Those are not placed at proper location. The number of points which are given in that particular area are not of required numbers. So the owner he tries to carry out some changes, additions, and undulations in his existing installation, and that leads to accident, because most of the time such changes and modifications are done by the layman. Some roadside wireman is brought and he carries out some changes, and that leads to the electrical accidents. So the National Electrical tells you about how many minimum number of points are to be given for the particular type of room, and how many different circuits are to be provided. Everything has been given in detail. Of course, your electrical designer has to consider that, and in accordance, he should coordinate with the interior design, which is given by the architect. Again, at this point, one thing is important, that the architect should give the proposed interior design layouts also. So in accordance, the electrical designer can locate prepare the layouts of the electrical points. So the accident may not happen. There are again different requirements in respect of ventilation, fan, down conductor, lightning protection system, earthing section that we'll see. So here you will see the location of plug points, where it should be, what care is to be required. Again, this is the distribution board. This is the distribution board. The location of this distribution is also mentioned, and there it should be in an accessible position without using tool or tackle. So the person in standing position should be able to reach and operate those switches within that distribution board. So these are the important conditions. In case of emergency, a person will go and switch off that circuit or incoming supply also. I have seen many times the distribution boards are located at such a height that the person cannot reach. It is near to the ceiling height. So it is not a correct way. See, short circuit, why it occurs? Many reasons are not do not directly relate with the architectural aspects. Some aspects relate with the electrical contractor also who executes the electrical work. So these are different joints within the wiring, bunching of so many wires bunched within the conduits. Incorrect if points are provided, number of points are not there, person may use the extension boards for the additional points. So this may lead to the fires. So this is again few of these things relate with the architect and the electrical designer. So in case of aluminum shuttered type construction, nowadays it is being popularly used. It is known by Maivan construction also. Here the total casting of walls and RCC work is done at the same time. Here again this point becomes very important. If there are no proper interior layouts, it will be difficult for the electrical person to locate the switchboards. And once the casting is done, this cannot be broken and you cannot make any additions and alteration into that. So here it is most important that the electrical layouts and interior layouts should completely match with each other at the very planning stage. Why again the accidents are occurring? Those occur because of the hotspots also which are within the electrical installation. These hotspots are not easily noticeable to your bare eyes. Once it is seen through the thermal camera, you will see some of the points which are not clearly seen here for the bare eyes. It can be seen that the temperature is rise at very high. Mr. Amol will explain you about these points in his presentation. This is the point again relates with the lighting fittings. I had been to one of the hotel a few days back. I have seen there is a light, ceiling light which was fitted here and it was dissipating a lot of heat. So I don't see it here. But it may happen because this device contains a driver within that, and if there is certain heat dissipating arrangement within that electrical fitting, that is called heat sink. If that is not properly designed, there will not be proper dissipation of heat, and it may lead to the heat. And heat is the worst enemy of the electrical installation. It damages electrical wires, insulations, and leads to fire. Batteries is another location where the accidents initiate. So in respect of batteries, where the batteries are to be stored, that should be well ventilated space, and certain specifications have been mentioned in the standards and code. Your consultant should tell you that how much space is required, how much air changes are required, whether the proper ventilation is there or not. So this point should also be considered at the time of your planning. Again, we have seen that some accidents initiate in the electrical appliances also. These are some of the pictures. I can show you a few examples of this. See what happens whenever somebody takes over the possession. Suppose he carries out the false ceiling for his existing ceiling. The height above the fan blades and the ceiling, that becomes less, and this creates a negative pressure between these two. This negative pressure leads to the heating of motor, and the motor may give way. So this is not correct. So again, this part relates with the planning of electric installation in your interior design. This is the picture of exhaust fan which is burned. Why exhaust fan burned? Again, if there is no fresh air intake arrangement to that particular envelope, it may lead to the negative pressure and your fan motor get burned. See here how the arrangement can be made is shown here. Suppose it is a washroom or your restroom door. certain intake arrangement is done at the bottom where from the fresh air can come in. So there will be continuous change of air and there won't be any negative pressure. So these are the details given in the National Electrical Code. Different conditions have been mentioned very nicely, and those are in a very much simple word. Of course, this has to be the complete within the knowledge of your electrical designer and consultant. One more point of conflict between the architect and electrical, I mean the provider of a lightning protection system is that the architects many times do not allow the down conductors to be taken from the surface of the building because that damages the aesthetics of the building. But as per the standards and codes, that is necessary, and it has to be taken from the surface of the building. Certain parameters are there, how much clearance should be maintained between two down conductors, how many conductors are required, how the earthing pit should be designed, all these details are given in the standard. So this is the inherent part. There should be some better way found out at the time of your planning only, how the down conductors should be taken. So these are some of the pictures from the earthing pits. See the earthing pits, earthing terminals, which are constructed in the ground, those have to be accessible all the time. What happens during the construction or the earthing pits are constructed and later on some pavement is done over that and it goes into the hiding. If some maintenance is required to be done, it becomes very difficult to find out where the earth pit was. So it has to be accessible. So it should be properly marked on the architect plans. This is the location for the earth pits, and that should be accessible all the time. Nowadays for high-rise building, the complete building structure, RCC reinforcement is earthed, and for that certain requirements are there. The bars are earth, and at the foundation level, certain earth grids is required to be done. These also points should be considered at the time of planning. If such type of earthing is going to be done, then such requirements related to such earthing should be taken from your electrical consultant. To minimize the risk of electrical shock, equipotential bonding is required to be done. So this is one of the picture of the equipotential bonding. Under this condition, all metal piping within the building is earthed, that is brought in the same potential so that there won't be any potential difference, a person can get electrical shock. So there are different departments which control all these activities. In respect of electrical, Department of Energy is there. Under the Department of Electrical Energy, Central Electricity Authority decides the rules and regulations. They have mainly published safety electrical. They have published so many regulations, but this is one of the important regulations, CA Measures Relating to Safety and Electric Supply Regulation. Recent edition was published in June 2023. There is Department of Fire. In Tamil Nadu state, the fire rules were published in 2014, I think. And fire NOC, certain processes have been mentioned for the fire NOC and the occupation certificates. Department of Urban Development, Town Planning, again building rules. I think they are still using APMBR. I mean Andhra Pradesh, I don't know whether Tamil Nadu has prepared their own rules. But in APMBR, I have seen that there are many checklists, very nicely designed, many checklists are required to be submitted for all the stages. I mean at the beginning of the construction, after completion and at the time of occupation. But in most of these things, points related to electrical are totally missing. So the greatest danger to building is not only, lightning, but electrical short circuits also. And if it is not taken care of, then again such type of occasions are again going to happen again and again. So coordination proper, I have not seen. So we are also on behalf of IC India, we are also trying to coordinate between different departments and try to unify all the rules and regulations for that. So what are the legal binding that we'll see from the perspective of Electricity Act? This is the Electricity Act. Under this Electricity Act, electricity rules and regulations are published, and the regulation mentions standards and codes. Standards and codes. So this is the Electricity Act. These are the important sections. Section 53, provisions relating to safety and electrical supply. Section 146 is punishment for non-compliance of orders and directions. Section 114 is offenses by committee. They decide the responsibility of the person. And Section 150 is the abatement. Shortly we'll see what this section says. I will read out the highlighted portion only. Whoever fails to comply with any order or direction given under this act, or contravenes, or attempts, or abates the contravention of any provision of this act, or any rules or regulations. See, they have mentioned the regulation. Rules or regulations made thereunder shall be punishable with the imprisonment or with the fine or both. So this is the provision under the Electricity Act. Who can be held responsible? That is mentioned here. Where an offence has been committed by a company, every person who at the time of offence was committed was in charge and was responsible for the conduct of business as well as company shall be deemed to be guilty. See here one proviso is given, nothing contained in this subsection shall render any such person liable if he proves that the offence was committed without his knowledge and he exercised all due diligence. I will give you one example. Suppose some requirement was there from the perspective of electrical designer, and that provision was not done by the architect in his architectural plans. And suppose if the accident investigation and if it is found out that there are no such architectural provisions, can we be held responsible? Yeah, he might be held responsible, but he might not be held responsible also if he has exercised due diligence. What is the due diligence? At every point he should consult the electrical designer. He should take his requirements. He should mutually agree upon those requirements, and there should be documentation for that. If he is able to produce that, he will not be held responsible. Abatement. So this is again abatement. You are not directly involved into the actual happening of the accident. Like you have not designed or you have not executed the work, but you are indirectly responsible. Like provisions required for the electrical is not done. That could be an abatement, and that is also punishable under this section. So these are the regulations which were published by the Central City Authority. So one important regulation change which has happened, which has made all the provisions of the standards and codes mandatory, is this regulation. Here you will see in the round circle, the shall word I have marked. The shall word was previously maybe. So the regulations may be followed, or provisions of codes and standards may be followed, the word was previously, but now the word may has been changed to the shall. So the shall has made everything mandatory, though the standards and code do not say those are mandatory, they always say those are guidelines, but the code has made all these provisions mandatory. So again the following of the regulations is involves legal implications. So these are the different codes and standards we are required to follow as per the standards. In the recently published one of the standard, one at IS 18732, there are the different stakeholders which have been defined here, and in this the different stakeholders responsibilities, architect's responsibility also mentioned quite clearly. In this chart given in this standard, these standards are, I will tell you, all standards are free to download. You can download all standards from the BIS site. So in this standard you will see here, so these are the different stakeholders. And under what regulations rules, there are certain mandatory things that has been mentioned in this column, and how to check whether those have been complied or that is given in this. So different tasks are mentioned here, different activities are here, and where to get this thing, check this thing whether complied or not. The checklists are given at the end of this as annex to this standard. So these are the different annexes. In all these annexes, architect's consent is required. Architect has to jointly sign the your checklist. So these are the different samples of the checklist where architect is involvement is there under certain conditions. So in Mumbai, as I told you, High Court had formed a committee, and they have given some recommendations, and the regulations have been revised in Mumbai, I mean for Maharashtra. So again I tell you there should be a coordination between the electrical contractor, consultant and different service providers that will lead to your good project. Thank you.